What's up, everyone? Today is Thursday, April 29th. Hopefully everyone is having a great day so far. To start off, we're going to go over the warm-up. Proportionality, so what we covered yesterday is obviously the warm-up we're doing today. So let's go ahead and get started. It says Miss Mathis can grade 2 essays every 15 minutes. At this rate, how many essays can Miss Mathis grade in 1.5 hours? So we need to set up a proportion in order to solve this problem. So I know that Miss Mathis, I'm going to put essays over minutes. You can absolutely do minutes over essays if you choose, but you just got to keep it the same way throughout. So she can do 2 essays in 15 minutes. And we're going to set that equal to, we don't know what the number of essays is, but we do know that she has a set time, 1.5 hours. Now, notice the labels that we chose to use are minutes. So we can't put hours there, especially because we chose minutes. So we have to turn 1.5 hours into a number of minutes. Now, I know that 60 minutes is equal to 1 hour, which means 30 minutes is equal to half an hour. So total 1.5 hours is equal to 90 minutes. Now, I don't know what the number of essays is, so I'm going to put an X. And now I need to see if I can find an easy scale factor. So if I were to zoom in here, 15, is there an easy scale factor to get from 15 to 90? If you know it, then it is times 6. So whatever I do to the bottom, I have to do to the top. So 2 times 6 is going to give me 12. So Miss Mathis can grade 12 essays in 90 minutes. Now, if you didn't know that, 15 times 6 is equal to 90, you can always cross multiply. So I have 15x is equal to 90 times 2, which is 180. Now I'm just going to use my solving tools. I'm going to draw my line down the middle. And I know when a number is attached to a letter, that means to multiply. So I have to do the opposite in order to get rid of it. So divide by 15 on both sides. And then let's see, 180 divided by 15. 15 can't go into 1. 15 can go into 18 one time. So then I'm going to subtract, get 3, bring down my 0. 15 can go into 30 2 times. So no matter which way you do it, you're going to get the same answer. Hopefully you got it right. If you didn't, hopefully you know what you did wrong and you can fix it next time. Okay, number 2. A recipe for a salad dressing calls for 2 teaspoons of vinegar to 3 teaspoons of oil. Based on the data, complete the table. How many teaspoons of oil will be used if 18 teaspoons of vinegar are used? So we're going to use vinegar to oil, and I'm going to set up a proportion. So I have 2 over 3 is equal to, it says how many teaspoons of oil will be used if 18 teaspoons of vinegar are used. So I know what the vinegar is, so I'm going to put that on top, and I'm trying to find this answer down here. Now, I need to see if I can find a common scale factor or an easy scale factor to use. In this case, I see that 2 times 9 gives me 18. That's simple. So that means 3 times 9 would give me 27. 27. So how many teaspoons of oil will be used if 18 teaspoons of vinegar are used? Boom, 18. And the first one, 2 teaspoons of vinegar to 3 oil. The next one is 8 teaspoons of vinegar to 12. And then the last one is 10 to 15. So you can solve these by doing exactly what we just did, by setting up a proportion and then solving from there. Hopefully you filled out the table correctly. If not, again, go over your work, maybe see what you did wrong. Okay, now we're going to flip on over. We're going to change gears, and we're going to go over to our cheat sheet. So go ahead and pull that out. Let me get there. Whoops, wrong one. All right, so today we're talking about percents. Hopefully y'all remember a little bit about percents, but if you don't, hopefully we'll jog your memory today. So the first one we want to talk about is percent models. Percent models. So if we look at the top two, or I guess the top, percent means out of 100. Out of 100. So right here I have 100 model or 100 square or whatever you want to call it. And there are 100 little squares inside each of these big squares, I guess you could say. So 30%, because it's out of 100, that means I need to have 30 of these little squares colored in. The same thing on the next one. It says 35%, which I know that percent just means out of 100. Therefore, there are 35 little squares colored. The next one is a percent bar. Or again, it's another percent model, but it's kind of like in a bar shape. So I have 1, 2, 3, 4, 5, 6 squares, and they are all colored. That's ugly. They are all colored, which means that's representing 100%. Now the next one, out of 6, how many are colored? 3. So 3 out of 6, that is exactly half, which means 50%. Now the next one's a little bit more difficult. There are 4 out of 6 colored. So what I would do is we're going to get into this a little bit more in just a minute. Or we did this yesterday. I'm going to turn 4/6 into a decimal, and then I would move it over. So I would divide this. I would get 66 and 2/3, and then I would move my decimal over to create a percent. Sorry. Okay, so you're going to end up with 66.67 after you divide. I think let's actually go ahead and do that. I might be wrong on that one. Oops. 4 goes on the inside, 6 goes on the outside. Can't go, so I have to add a 0. 6, 6, 36, 4, 0 again. Okay, look, and we're just going to keep going and keep going and keep going. So I would end up getting 0.6667. And then in order to turn a decimal into a percent, like we talked about yesterday, you just move the decimal over 2 times. So that's how I get 66.67% or 66 2/3%. Now, let's move on to benchmark percents. Benchmark percents. So benchmark percents just means that these are really common and that it would be very helpful for you to maybe memorize some of these. So the top one, it says from 0 to 1, but then it's broken up into 1/4, 1/2, and 3/4. A way that I find this easy to remember is quarters. All right, 1/4 is equal to 25 cents. 2 quarters is equal to 50 cents. 3 quarters is equal to 75 cents. And then 4 quarters is equal to 100. So this one actually out here would be 4/4. And then 1/2 would be 2/4. Those are equivalent fractions. The next one that is very common is thirds. So 1/3 is equal to 33 1/3%. 2/3 is 66 2/3%. Now it's going to be very helpful for you if you can memorize these. It's going to take a lot less work in the long run if you can memorize these. And then lastly, we have into 10%, 1/10, 30%, 3/10, 50, 5/10, 70 7/10, 90 9/10, and 1 is equal to 100%. Okay. So very helpful if you can remember those benchmark fractions. So now let's talk about percent proportion. So we're going to use this proportion whenever we're trying to find a percent in a word problem, or when we're trying to find the part, or when we're trying to find the whole. We're going to set it up this way. You can either set it up percent over 100 or and then equals part over whole, or part over whole equals percent over 100. You're going to end up getting the same answer. So either way that you choose to write it, completely up to you. As long as you know what each of them mean. So percent, again, is out of 100. So a quantity, that's an eraser, not a highlighter, a quantity out of 100. So in order to solve this, we're going to set up a percent proportion. We're going to solve for the missing quantity, and then we're going to reread the question to make sure that we answered it. So example number 1, it says 72% of students buy their lunch at school. If there are 300 students at school, then how many buy their lunch? So what they did percent. So I'm going to do percent is 72. They did 300 students at their school, so that would be the whole. And then they're trying to find out how many buy their lunch. Now, in order to solve this, the first thing that I'm going to do is I'm going to see if there is a easy scale factor. In this case, there is. 100 times 3 gives me 300. And whatever I do to the bottom, I have to do to the top. So 72 times 3 is 6 and 21. So the number of students who buy their lunch are 216 students. Now, what they did, instead of finding that scale factor, they just cross multiplied. So they did 100 times x is equal to 300 times 72, which is 21,600. And then they divided 100 by both sides, kind of what we talked about yesterday. Okay, example number 2. It says 64 students buy their lunch at school, and this is 16% of the total student body. How many students are in the school? So what they did, they put 16 over 100 because 16 represents the percent. And then they put 64 as the part because 64 students buy their lunch, which means we all kind of know that a bunch of kids bring their own lunch to school so they wouldn't have to buy their lunch, which means we're trying to find the total number. So let's look at it. If we zoom in, we need to see if there is a common scale factor. So in this, or not a common scale factor, an easy scale factor. In this case, there is. 16 times 4 gives me 64. And whatever I do on the top, I have to do to the bottom. So 16 times 4 is 64. 100 times 4 is 400. Now, they also gave you another example right here and right here, that what they did, instead of finding that scale factor, they cross-multiplied. So 16 times x gives me 16x. 100 times 64 gives me 6,400. And then you just have to divide to get that x by itself. So hopefully this was helpful to you. As always, you can pause and re-listen or come back to this video if you're maybe struggling a little bit with percents. So after you do this, you're going to start your activity for the day. I talked to Ms. Shaheen and Ms. Vickers, and if you have questions, you are more than welcome to go ask them. All right. I hope y'all have a fantastic, fantastic Thursday, and I'll see you tomorrow. Bye, guys.